Hi, welcome to the N3tstat IDS introduction demo. Before we begin, I recommend you go to www.networksec.com. Notice the 3 in place of the first T. Go to the Products tab. Follow the N3tstat IDS repository link, which will take you to the N3tstat IDS GitHub repository, where you can find the latest N3tstat IDS version available for download and the most recent documentation. Review of the N3tstat IDS overview presentation is recommended prior to watching this demo. Here's where the presentation's at. Back to the demo. N3tstat IDS framework is a lightweight next-generation endpoint detection and response framework designed to better detect the presence of malware employed by an advanced cyber threat, offering the visibility and context required by cybersecurity analysts to perform proactive threat hunting. N3tstat IDS is made up of 3 main components: N3tstat IDS Agent, N3tstat IDS Server, and N3tstat IDS Analyzer. N3tstat IDS agents are grouped and organized by sites. The N3tstat IDS server collects and records results from all associated N3tstat IDS agents for further analysis by the N3tstat IDS Analyzer, which also runs on the N3tstat IDS server. The N3tstat IDS Analyzer is the GUI component of the N3tstat IDS framework. So how does N3tstat IDS perform detection activities? Each agent continuously collects and performs initial analysis on endpoint metadata in order to identify behavior characteristics generally associated with an advanced cyber threat. Endpoint metadata includes network session information, including associated running processes, whois and DNS info, and logged-in user information. The results of this continuous analysis consists of flagged network sessions having characteristics resembling those of beacons employed by an advanced cyber threat. Determining what processes and users, that is, process owners and logged-in users, are accessing a remote system over time can lead to the detection of malware and associated indicators of attack, such as code execution, privilege escalation, establishing persistence, process migration, lateral movement, and command and control. Here we have the N3tstat IDS Analyzer interface, or the N3tstat IDS framework GUI. The N3tstat IDS Analyzer presents a real-time holistic view of endpoint activities from an enterprise network perspective. It facilitates analysis of collected results for all monitored endpoints and significantly reduces the effort required to identify and filter out legit behavior in order to focus analysis efforts on suspicious endpoint activities. As you can see on the left pane, we have remote endpoints organized by Regional Internet Registry, or whois registrants. These remote endpoints are endpoints being accessed by monitored endpoints, that is, systems running a N3tstat IDS agent, via an outbound network connection having characteristics resembling those of a beacon employed by an advanced cyber threat. Each remote endpoint has an indicator, which we will discuss later, and is made up of the remote IP address and the TCP port. Underneath, here's the indicator and the IP address. Underneath each remote endpoint, you also have associated DNS information, if it is available for that particular remote endpoint. There's a few examples. Selecting a remote endpoint populates the data tables with associated information. The top table is the findings table. It lists the identified findings or potential indicators of attack associated with the selected remote endpoint. Some of the indicators of attack detected by N3tstat IDS are the following. It identifies processes like PowerShell, conhost, or LSAS, accessing a remote system via web-based protocol, for example HTTPS, over an established network session. This could be indicative of code execution and command and control. Processes owned by N3tstat authority system accessing a remote system via a web-based protocol over an established network session. This is also indicative of code execution and command and control. It also identifies processes that are running when a user is not logged in and are accessing a remote system via a web-based protocol over an established network session. This could be indicative of persistence. It also identifies multiple processes from a single endpoint or multiple endpoints accessing the same remote system via a web-based protocol over an established network session. This could be indicative of a process migration, privilege escalation, lateral movement. Back to the analyzer, the middle table lists the processes or beacons along with the corresponding IP address of the agent or client that were flagged that are running on the monitored system and are accessing the selected remote endpoint. The bottom table lists the agent's clients along with their corresponding site where the identified or flagged processes or beacons are running and are accessing the selected remote endpoint. There are also built-in CAN reports accessible by right-clicking the column 1 element of each row. The resulting reports provide a cyber analyst with additional detailed information associated with the remote endpoint. For example, you can right-click finding type 101 to find all the processes or beacons with process owner N3tstat authority system accessing the selected remote endpoint. The results show up in the query path pane. As you can see, the output contains additional time and date information of when the process or beacon was first detected and when its latest activity was detected. What we just went over is the remote endpoints view. N3tstat IDS also offers an agent's view. In the left pane, we now have agents organized by site. The listed agents are all the agents being monitored by the instance of N3tstat IDS server. Each agent also has an indicator which we will discuss later. The IP address showing is the agent IP address. Underneath each agent IP, you also have a client socket IP address. The client socket IP address is the IP address that communicates with the N3tstat IDS server and can be different from the agent IP. This is common in cases, for example, where the N3tstat IDS server is hosted in a separate physical network external to where the agents reside and the agents have private IP addresses assigned. Like in the remote endpoints view, selecting an agent populates the data tables with associated information, and there are also built-in CAN reports for obtaining additional detailed information associated with the selected agent. Let's run this report again. As you can see, we find all processes having or running under an N3tstat authority system that are running on the selected agent. So it lists all those processes, the command, the process ID, the remote endpoint it's accessing, when it was first detected, and when its latest activity was detected. Let's run another report. Let's run this particular one. Let's get all the processes or beacons. So basically we're getting all the beacons running on the selected agent that are accessing the remote endpoint that we right-clicked. As you can see, it's a total of 2, and then it also has the time and date detection information. N3tstat IDS also offers you the capability to filter information by site. This is useful when a cyber analyst wants to focus threat hunting efforts on a specific site. Here we have all sites selected, but if we select site 1, it filters out all the nodes under site 2. If we go to site 2, it filters out all the nodes under site 1. Now we're going to switch back to the remote endpoints view and talk about the built-in rule sets and how they can be used to filter out legit endpoint activities traffic. What I'm about to show is easier to visualize in this particular view. So let's expand our registrant sites, and then let's clear the query pad. Before continuing, I want to clarify and point out that all the information shown as part of this demo represents metadata associated with legit, trusted, non-malicious traffic. Currently working on and coming soon will be a demo showing N3tstat IDS capabilities to detect advanced cyber threat PowerShell-based tools typically used to evade legacy antivirus IDS systems. But back to this demo, when I started doing this research, it was an eye-opening experience to see how many non-malicious beacon applications like Microsoft programs employ. There is a significant amount of those types of activities taking place. This presented a challenge in trying to achieve the overall objective of reliably detecting malicious advanced cyber threat activities. The implementation of the rule sets I'm about to go over helps significantly in overcoming this challenge. There are 4 rule set options. One of them is none, default, custom, and custom ERA. So let's select the default rule set and notice what happens to the left. So we expand them out. After selecting, we see that a lot of the remote endpoints were filtered out. The default rule set contains a read-only list of known remote endpoint IP addresses associated with legit, non-malicious trusted traffic. This rule set is periodically updated, that is, every time a new release is made available. So this list was read-only, so now let's expand again, and so we went back to no rule set, so everything is available again. So now let's go to the custom rule set, and a similar behavior occurs where remote endpoints get filtered out. The custom rule set is a read-write list that contains the same list of trusted remote endpoint IP addresses as the default rule set. In this particular scenario, when the custom rule set is selected, a cyber analyst can begin filtering out legit traffic activities by adding selected remote endpoints to the rule set. For example, after doing analysis on this particular remote endpoint, we deemed that the activities here are legit, non-malicious, so probably want to filter this out so we can add it to the custom rule set. Hit refresh, and if we expand again, you see that it's no longer there. We can also go to configure rule sets to view and edit the read-write rule sets. So let's go there, and then as you can see in this dialog, each rule set has the description we just went over. There's the default, which is read-only. There's the custom, which is read-write. And wanted to go to this dialog to take the opportunity to verify that the remote endpoints that we added to the custom rule set are here. So as you can see, we scroll all the way to the bottom. You can see the remote endpoint we added. All the other listed endpoints are the default pre-populated endpoints that have been determined as legit, non-malicious endpoints associated with non-malicious activities. So let's go back. So N3tstat IDS also offers the capability to add all the remote endpoints contained under a whois registrant container to a custom rule set. For example, let's say we've analyzed all these endpoints under Microsoft Corporation, and we've determined that there are non-malicious activities there. So instead of adding each individually, you can just go to the registrant, right click, and say add all IPs to rule set custom. We refresh and all the Microsoft Corporation IPs are filtered out. This last feature greatly simplifies the data reduction process, allowing a cyber analyst to easily filter out legit trusted non-malicious activities in order to focus on threat hunting activities. So the last thing to cover is the Endpoint Risk Analyzer, which we have over here. So first, let's just go to our entire view of remote endpoints. So the ERA is a service that provides automated analysis of the endpoints, that is the remote endpoints and agents, based on the existing ERA rule sets and existing built-in rules thresholds, to help detect advanced cyber threat activities and assign a risk to the particular endpoint. Here we're gonna, oops, wrong button. We're gonna start the rule set, the Endpoint Risk Analyzer. You can see it's running, and then we're gonna give it some time to go through each of these remote endpoints. This is where the indicators come into play. As these endpoints get analyzed, you're going to see that its color change. A green indicator means that the remote endpoint presents no risk and is trusted. A yellow means that there were suspicious activities detected and a medium risk score had been assigned. Red means that there were severe suspicious activities detected and a high risk score has been assigned. As mentioned earlier, in this particular demo, all the information shown represents metadata associated with legit, trusted, non-malicious traffic. So let's hit refresh and see how we're doing. We got some results back. As the ERA is running, a cyber analyst can be inspecting and analyzing endpoint activity simultaneously and updating the rule sets to filter legit, non-malicious activities. For example, the cyber analyst can inspect the activities of all remote endpoints associated to a specific whois registrant and determine that all remote endpoints are associated to legit, trusted, non-malicious traffic. So let's take this MCI Communication Services remote endpoint. We can see that it was assigned a high risk. Reason why it was assigned a high risk is one of the things that N3tstat IDS checks for is the length of the command, which long commands are common in PowerShell stagers or payloads. So N3tstat IDS is going to flag it. In this particular case, though, this command is a legit command, is not a malicious command. So let's just go here and let's go to configure rule sets, which can also be accessed from this shortcut. And then let's say we were able to determine that the behavior associated to this remote endpoint was non-malicious. So we can go to this tab, the whois registrants tab, add that particular whois registrant so that it's trusted, and then we can save the configuration, and then on the next go around the ERA is going to determine that this is trusted traffic and it's going to change its status. Let's give it some time. Let's refresh, and there it is. So now it's trusted traffic, so its indicator is green. Now, like I mentioned earlier, risk is also assigned to the agents. So if you go to the agents view, you can see that this particular agent or monitored endpoint has a yellow risk. Basically, the risk factor assigned to an agent depends on the assigned risk factor of the remote endpoints its processes or beacons access. If the risk factor for all corresponding remote endpoints is 0 or green, the monitored endpoint also has a 0 risk factor, which is this case here. Here probably one of the endpoints had a medium risk factor, so that's the yellow indicator here. So this concludes the N3tstat IDS introduction demo. Please feel free to contact us with any questions you may have. Your feedback is welcome and greatly appreciated. Thank you.